Hello everyone, you're welcome in this video. This is the part 4th of mensuration, and in previous 3 video, part 1 we have studied cylinder, then part 2 there was cone, and in part 3 there was sphere and hemisphere. But in this part, that is in part 4, we will study about the combinations of solids. You see an ice cream, so the lower part is a cone and the upper creamy portion is, you can say, a hemisphere. Okay, so this is the combination of two solids, that is cone and hemisphere. Similarly, this is the tent, and the lower portion of the tent is in cylindrical shape and the top portion is in the conical shape. So this is the combination of two solids, that is cylinder plus cone. And suppose this is a capsule shape. So in between the green portion is cylindrical and two pink portions, upper end and the lower end is hemisphere. So it is the combination of one cylinder and two hemisphere. So these type of combination we are going to study in this video, but you have to remember the following formula, otherwise you will not able to solve the question. So what are those formula? Just have a look. Like volume of the cylinder, pi r square h, volume of the cone, same formula but 1 by 3, so 1 by 3 pi r square h, volume of the hemisphere, 2 by 3 pi r cube, curved surface area of the cylinder, 2 pi r h, curved surface area of cone, pi r l, and curved surface area of hemisphere is 2 pi r square. So I think you have already studied all these shapes, and I think you have remembered these formula. So going towards the question, what type of question we will have to face. So this is the first question. In this question it is given a toy is in the form of a cone of radius this mounted on a hemisphere. So what type of solid we are having? It is the combination of one hemisphere and the cone is mounted on the hemisphere. So this is the combination of cone and hemisphere. So dimensions are given. If the total height of the toy, this is here to here, it is given 15.5 centimeter, and because radius of the hemisphere and cone are same, which is 3.5. Now tell me what is this length? This is 3.5. because this is the radius of hemisphere, which is 3.5. Now whole length is 15.5. if I am subtracting 15.5 from 15.5, if I am subtracting 3.5, then I will get this value, which will be the height of the cone. So what was the height of the cone? 15.5 minus 3.5, which is 12 centimeter. Now because curved surface area, we must know about the slant height. So h is given 12 and r is 3.5. So by using Pythagoras, that is this formula, L square is equal to h square plus r square. So we will use this formula. In place of h, I will put 12. In place of all, r 3.5. Now by calculating, L will be 12.5. So this way I have calculated L. Now coming to the curved surface area, in this solid we need to find curved surface area. So curved surface area of the cone plus curved surface area of the hemisphere. I want to tell you one thing. There are two ways to solve this question. First, find the curved surface area of cone separately. Then find the curved surface area of hemisphere separately. Then add these two. So it will create a burden of calculation. So here I am telling you that just put the formula first. Okay, what is the curved surface area of cone? Pi rl. And what is the curved surface area of hemisphere? 2 pi r square. Then pi r is common, then L plus 2r. So this is called, I have taken pi r as a common. So pi r as a common, it will reduce the burden of the calculation. Now put the value of pi, which is 22/7. Then put the value of r, which is 3.5. Then the value of L is 12.5. Then 2 into r, that is 2 into 3.5. Now after calculation, this is your answer. So this was an example of combination of hemisphere and cone, and curved surface area is to be found. So curved surface area of cone plus curved surface area of hemisphere. So I have told you the technique that take pi r as a common. It will reduce the burden of the calculation. Now coming to the question number 3. Here we have a question number 3. So in this question it is given that just near a rocket is in the form of a right circular cylinder, okay, at the lower end and surmounted by a cone. Okay, so this type of figure we are having. This is a type of rocket. So lower portion is the cylinder and upper portion is the cone, and obviously in this case the radius of the cone and the radius of the cylinder will be equal, and slant height of the cone is given 5 cm and height of the cylinder is given 12 cm, and radii of both cylinder and cone is 3 cm. Now we need to find the total surface area of this solid. This solid is having 3 surfaces. Number 1, this flat surface, which is the base area of the cylinder, flat surface, base area of the cylinder. Then blue part, curved surface area of the cylinder. Then green part, curved surface area of the cone. So total surface area will be base area of the cylinder, which is a circle, this portion. Then curved surface area of the cylinder, this portion, blue portion. Then curved surface area of the cone, that is the green portion. So pi r square is the base area, then 2 pi rh is the cylinder curved surface, then pi rl is equal to the curved surface area of the cone. And I have told you the technique. Write the formula, then take pi r. Pi r is common in 3, so it will reduce calculation. So it was already told in the question that pi is to be taken 3.14. So I am taking pi 3.14, then r value 3, then I am substituting all the values, that is r, h and l. So by calculation, this is the total surface area of this solid. Now we also find volume. So volume of the cylinder, volume of this rocket. So it is having cylinder and cone. So what will be the volume? Volume of the cylinder plus volume of the cone. So what is the formula of volume of the cylinder? Pi r square h. What is the formula for volume of cone? 1/3 pi r square h. So pi r square is common, but in this h and capital H are different, because h is the height of the cylinder which is given, but capital H, that is the height of the cone, was not given. We were having only radius and slant height. So radius, height of the cone and slant height having this relation, Pythagoras. So with this formula I have calculated the height of the cone, that is 4. So now putting all these values, pi r square was common, the value of h, that is the height of the cylinder, capital H is the height of the cone, and after calculation, this is my answer. This is the volume of the this rocket. Okay, so now come to the question number 3. Question number 3. In this question, it is given that in the adjoining figure, which represent a solid consisting of a right circular cylinder, and at one end hemisphere and other hand there is a cone. So this is the combination of 3 solid: hemisphere, cylinder and cone. Okay, hemisphere, cylinder and cone. And the height of the cone is 4 and the height of the cylinder is 4, and radius of these 3, radius will be common. Radius of the hemisphere, radius of the cylinder, radius of the cone is common, which is 7 centimeter. Now what is the volume of the solid? So volume of the cone, number 1, volume of the cylinder, number 2, and volume of the hemisphere, number 3. So these 3 volume is to be add. So volume of the cone 1/3 pi r square h, volume of the cylinder pi r square h, and volume of the hemisphere is 2/3 pi r cube. And I have told you, take pi r square is common. It will reduce your calculation. So the value of pi is 22/7 and r square, because r is 7, so r square 49, small h 4, small h again 4, then 2 by 3 and the value of r is 7. After calculation, this is our answer. So this way we can solve these questions. Now in next video we will study about the conversions of solid in part 5. So keep watching my video. Thank you very much.